The recursion never ends. Make it stop. Make it stop.
Alright, welcome programmers and programmers to be. This video is going to be on recursion, how it works and what it is. In order to demonstrate what recursion is, I'm going to be using an example of the sum function. Let's start by creating the name of our sum function definition, and this will be the function for the standard way of calculating the sum. Let's call the function standard sum, and as input we'll give it a list. Let's create a variable total starting at 0, keeping track of the running sum. We create a for loop to loop over all the numbers in the list. We add each number num from that list to the total. Once we've looped over all the numbers in the list and added them to total, we can now return total as the sum of all the numbers in the list. Now let's create a recursive variant of this function to see how recursion works. Just as before, recursive sum receives a list of numbers for which it must compute the sum. For a function to be defined as being a recursive function, the function that we define, recursive sum, must call itself. So, recursive sum must use recursive sum in some way to compute the actual sum. It is important for recursive functions to contain a base case, because a function calling itself will call itself indefinitely. So let's create a base case for our recursive sum function. Let's look for the base case where the recursive sum function receives an empty list. If the list is empty, we determine the sum of the list to be 0. But in our case, it is important that we pick 0 because it doesn't influence any previous sum. If we've got a sum of 20 and we add the sum of an empty list, namely 0, it remains to be 20. If we would, for example, be multiplying numbers, our base case might return 1, since 1 times anything will stay the same as well. Let's look at the interesting part now and see what we should do if the list is not of size 0. If the list is not of size 0, there must be at least one element inside the list. And the logic for a recursive sum is as follows. The sum of the list is equal to the first number in that list plus the recursive sum of the rest of the list, where the rest of the list is the list not containing the first number we took out. So let's create that in code. Let's create a variable num to store the first element of the list. Let's then create a variable rest to store the rest of the list. Rest of the list being the entire list except the first element. That is why we set rest equal to list from index 1 till the end. Now we can return the sum using recursion. We say that the recursive sum is equal to the number we just took out plus the recursive sum of the rest of the list. We now say that the recursive sum of a list that is not empty is equal to the first number in that list plus the recursive sum of the rest of the list. We can write it like this to save some space. Let's print out the result of these functions to see if they return the same result. Let's execute the code. As you can see, both of the sums are equal to 15, and this is correct. Let's dissect how the recursive method works one more time. The recursive sum of the list 1, 2, 3 is equal to 1 plus the recursive sum of 2 and 3. We then compute the recursive sum of 2 and 3, and we see that it equals 2 plus the recursive sum of 3. Let's now compute the recursive sum of a list containing 3. The recursive sum of a list containing 3 is 3 plus the recursive sum of the rest of the list, which is empty. Now we're going to reach the base case of the recursive function. We want to calculate the recursive sum of the empty list, and from the base case up here, we know that the recursive sum of the empty list returns 0. Now that we've completed the base case, let's move up the recursion chain and replace the results we found. We grab the 0 and replace recursive sum of the empty list with 0. We see that the recursive sum of a list containing 3 is 3 plus 0, so let's grab 3 plus 0 and replace the recursive sum of a list containing 3 with 3 plus 0. Here we see that the recursive sum of 2 and 3 is equal to 2 plus 3 plus 0 after the replacement, so let's grab 2 plus 3 plus 0 and set the recursive sum of 2 and 3 equal to 2 plus 3 plus 0. We can now see the final result of the recursive sum of 1 plus 2 plus 3. As you can see, the recursive sum evaluates to a normal summation of the numbers in a list. We now completed the result of the first recursive function call and can remove the old results. Finally, let's evaluate the calculation that is left, and we see that the result of the recursive sum is 6, which is exactly as we expect from the sum of 1, 2 and 3. I hope this video was helpful in showing you what recursion does and how it works. Please leave a like and subscribe if you enjoyed. Peace!